if you were not on the call yesterday, we mentioned that for you to be able to run the platform Jupyter notebook that allows you to run codes or Python codes to do basic or all forms of statistical analysis and any form of coding, you want to install Anaconda Navigator. And having Anaconda Navigator installed, you can then launch all the platforms. So we have the Jupyter Lab, the Jupyter Notebook, which you are going to use, and other ones. So the RStudio is also here that a lot of people use for their statistical analysis. And we want to tell you that you should keep watching our ability channel, because very soon we'll start featuring a lot of videos or analysis that uses the RStudio. So I'm going to share the screen where I have launched my Jupyter notebook, and then we'll run our codes from there. Yeah, so if you can see my screen, just give me a thumbs up or something so I know you're following. Let's react. Let's type in the comment section. Let's type following so that I know we are following there. But in the meantime, I am pasting. I'm pasting the link to the video I shared earlier here so that you can just follow the link, and then all the questions you have, you address them as the MC will talk about. So yeah, so that's the video. So we continue with the coding. Right, so if you were on the call yesterday, we mentioned that before we can be able to import our data set into the platform to run in the form of analysis, there's a need for us to import some packages or some libraries. And one of the libraries is pandas. So I would quickly just go over all of that. So I can delete this one and then we put it again. So we import. So we import. Let me delete everything so that we start afresh today. So I cut. Okay, cut. Okay. I'll rerun the console or the kernel. Right. So it is now fresh. Let's start. So we have to import library pandas as PD. So it means that wherever we are going to type PD, we are referring to pandas. And you press Shift and Enter, and then within a while, once this asterisk changes to 1, it means the command has successfully run. So wait for that to happen, and I think it will happen very soon. Yeah, so once we wait for that to happen, we'll continue. So we are given a command that it should pull out our data from wherever we have saved it. And we want to name that data as DF, data frame. So PD dot read underscore CVD. CSV rather, CSV. Right, so we realize that it has checked 1, so it has finished importing that library pandas, and so we can use it here to read our CSV file. So what is so here we are going to give the path location to the data. So when you check here, I have my data in a folder called Catalytics. Yes, so I have it in a folder called Catalytics. So I'll copy Catalytics. So I'll copy Catalytics. And then when I open that folder, The data is called demonstration catalytics. Copy demonstration catalytics. Right. So yesterday I typed this myself and I realized there was a mistake in the spelling of demonstration. So there was a error code that came. So today I am copying it. So you realize it has also run successfully. There's no issues. So once you have imported your data, there's also the need for us to import some other libraries, and that is SciPy. We import from SciPy, we import stats. So we type from SciPy import stats. That is not all. We also import SciPy as SciPy, and then we also import one important one, NumPy. Also import NumPy as NP, and then we also import matplotlib dot py plot as what plt. These are libraries that will help us to do anything related to mathematics or statistics. So wait for these libraries to load. We hope that there's no error code that appears. So looking at it, everything is fine. So it should run. Everything is fine. So yes, perfect. So it has also run successfully. So after importing the libraries, the next thing is to first run our QQ plots. So we want to see visual inspection by drawing our PP plots to see how the data looks like. So we are going to type this code stats dot probability as prop plots into brackets. Here we are going to define the data frame. So we want the data, we want these plots for a particular, and before then, let me run a code that help us to see what data we are even working with. And so that data we are working with is df dot. So we want to see the first four. Yes. So this code helps us to see the data we are working with. So it gives us the first 5 inputs for each of the data. So it's a data that has age, BMI, and so on. And these are the values. So knowing that these are the data we have, we want to make a probability plot for let's say FBG, and then we'll do for age and then see what differences we can see with the plots. So probability plots. So DF. So we are doing it for FBG first. Add drop NA. Drop NA. And then we want it to print plt.figure. All right. Yeah, the reason it didn't print out anything is because we didn't finish there. So we actually wanted to plot for us, so we didn't give that command to plot equals yield. So let's see what happens this time. Good. So that was a little error we made in the first code, but so when you look at this drawing. This is the probability plot, just as we saw in the just earlier on. Right. So from this, what can we say? Well, let's run the Shapiro week or the Shapiro stats and see what value that would also give us. So DF. So we just come and copy this so that let's copy this and see. Okay. So add dot NE. Good. So so here it also gives us the second value here is the probability value, which is the p-value. And it's telling us that this probability value is less than 0.05. So it is significantly different from a normally distributed data. That is what this interpretation is saying. Now let's run the same code for let's change it now. Let's run it for age. So we'll change this to age. And then we'll see what value comes. Okay. And then we run the Shapiro code on it and see how. Yeah, so equally this one too is also less than, it's also not normally distributed because the p-value. So we can do it for a number of them. So maybe we can select, let's select uric acid and see what happens. Okay, so let's select uric acid. Uric acid. Yeah. Okay. And then let's say stats. Stats dot Shapiro. Yeah. So this is not statistically significant. So when you look at this p-value, this is greater than 0.05. So it helps us to see that this data is not significantly different from a normally distributed data. So we can compare this drawing here, this probability plots with this ones and this one. You can see a little deviation from here. So we can see a little deviation from this one and this. But when we come to this, it seems all the data points seem to lie on the 45-degree line. So this is one way we can be able to do a normality test using the Python platform.